Hello, welcome back to More Fun Fixing It. It's time for a Spectrum repair. I've got this one. Now, I have got huge down here on the floor behind me. There's some in a box here as well. And there's some over here in a box over here. But I have got a huge pile of ZX Spectrums that Paul, Universal Retro Boss, has sent over for repair. And this is the first of the batch of, I think it's about 50 machines. It's not all ZX Spectrums. There's some Commodore 64s in there as well. There's even an Atari 400. I know. But this one, I've picked this out of the pile because I spent a lot of time yesterday going through all of them and triaging the ones that will make videos and putting the other ones, or actually just composite modding the other ones and sending them back to Paul. But this one stood out to me. I've already taken it apart, all the screws are out, and I've written on here, interesting, screen, corrupt screen, black and white, 16K, issue 2. So, as we can see inside, this is a lovely example of an issue 2, one of the most popular versions of the computer. Not popular in everybody wanted it sense, but this was the one that was sold, I think, the most versions. Not necessarily, again, the 16K version, but an issue 2 board was a very popular one. And I think that this is the actual machine, not the actual machine. I'm doing a lot of correcting here. The actual version of the machine that I owned as a lad, because mine was a 16K, and it would have been an issue 2 because it was at the right time, 1982, around Christmas. It wouldn't have been an issue 1 because they didn't make so many of those. So mine would have come like this, with these empty sockets for the upper RAM and the logic chip associated with them, also logic chips associated with them, also socketed, with single wipe sockets, which is a bit of a shame. So let's have a look at what this one's doing first of all. Okay, so I've got my bench power supply set to 9 volts at 800 milliamps. I've got a normal composite lead plugged in here. I've already composite modded this one off camera, so you don't have to watch that. It's got all its original caps in and everything else is untouched. That's the only work that I've done to this. All right, here we go. Yeah, look. So this is what we're getting. It's kind of in fact, it's more flashy on the screen that you can see there than my bench screen here. On the bench screen, it just shows a black and white picture. So I've already changed the ULA. I've taken the ULA out and put a different one in. But I think the thing to do here is to actually take this ULA and put it in another machine. Right, and for this, I've got my stunt Spectrum here that named after Dean from Breaking to Program. He named his test Spectrum his stunt Spectrum, which I thought was really cool. So I've got a stunt Spectrum as well now, which is a fully socketed, apart from the LM1889 chip, fully socketed issue 2, and it's a nice easy machine to work on. I have got an upgrade to do to the video circuitry as well to make things a bit more interesting. Just pulled a pin out there in this socket. Not pulled it out, but stretched it. Oh, now I've gone the other way. Yeah, that might need a new socket. Anyway, let's get this one in there and see if it works. Right, so that's a normal ULA. There's nothing wrong with that. Okay, so the ULA is good. It's all very well working on something safe and plentiful like my beloved ZX Spectrum or Commodore 64. There are literally millions of these things being dug out of sheds and attics all the time. But what if you want to explore something a bit more obscure? Buying a rare vintage computer like a Computer's Lynx these days is a huge investment. But there is another way, which brings me to the sponsor of today's video, PCBWay. Thanks to the amazing retro community, enthusiasts are actively reverse engineering these incredibly rare machines. So instead of hunting down an expensive fragile original, you can take those open source files, upload them to PCBWay and have a brand new professional quality replica manufactured. Take these Computer's Lynx PCBs I was generously donated. PCBWay makes bringing a forgotten system like this back from the dead completely accessible. And if you're building smaller expansion cards, parts, memory modules, or custom adapters to get these obscure systems running on modern displays. They can fabricate standard boards up to 100 by 100 millimeters for just $5 for a batch of 10. They can even 3D print missing keycaps or CNC machine custom cases to finish the build. Don't let rare hardware become a lost piece of history. Check out the link in the description to get your custom boards and parts made. Big thanks to PCBWay for supporting the channel. And to Lester for sending me these. There is something I don't like about this one, which is this socket for the ULA is really, really horrible. But I have already, when I tested this before, I did give the socket a good contact clean, so it should work. And it feels like it's going in there okay. But that's something to bear in mind maybe for later. But I don't, you know, you would expect if it was a poor contact on the socket to be making a difference if you're pulling it around. Anyway, let's get this one out of the way and let's try to work out what's going on with this one. So it could be just these variable resistors. And but it doesn't look like it is. Now let's try diagnostics. So we've got a working speaker, that's good, because the issue 2s use 200 ohm speakers and I haven't got any spares of those, so I'm quite pleased to see that. I'm noticing that that crystal really looks in poor condition, like it's suffered some heat damage. Right, so that's passed all those tests, but there definitely looks like there's some... There looks like there's memory problems or some kind of problem on there. I do have a socketed ROM. Now the ROM would be taken out of the equation. I can actually remove the ROM altogether and still run the diagnostic, so we can eliminate that quite easily. Yeah, still doing the same thing. Okay, let's check the simple stuff first. Oh, I'm looking at the ULA. 1, 2, 3, 4, 5, 6. Okay, so that is a good clock. Okay, on the CPU, pin 6. Sorry, my apologies. It's been a while since I worked on a Spectrum. Okay, I'm obviously going to edit all of that bit out now so that I don't embarrass myself. But yeah, nobody should be measuring the CPU clock on the ULA. That would be stupid. 1, 2, 3, 4, 5, 6. Yeah, that's a normal clock. Good. Now, let's just make sure it's coming out of reset properly, which I suspect it is. So it's 1, 2, 3, 4, 5, 6. Quite a quick reset, so it could be caps related, but I would expect if I pressed and held down reset on the Steam Card Pro that it would come out of reset more elegantly. So I don't think it's that. Okay, let's check voltages. So a good 5 volts coming out of the regulator. Minus 4.76 on the 5 volt rails, 12.31 on a 12 volt rail, and 5.06 on the 5 volt rail. It's only drawing 692 milliamps as well. Okay. Right, so the first thing I think I should do, and this is all, Dean's going to get another mention. Dean, Break Into Program, Dean is going to get another mention because this is taken from his website. Go and Google Break Into Program and you'll find a fantastic blog-style website where he does lots of repairs and all sorts of really interesting projects. And a very, very clever man. Really likes his Tatung Einstein. So I'm just going to put this here and I'm going to check the pinouts for the ULA. Specifically the ones to do with clock and the video out. So we've got the the UVY here, but it's not YUV. It's not what you expect. There are two colors and a chrominance or luminance. I don't know what they mean. Plus the clock signals. So we've got Q and clock over here. So we've got Q, which is the 14 megahertz from the crystal. So from that one. And I think this one is to do with the parts of the color generation. So we'll get into that in a little bit. But there's also clock, which is the clock source to the Z80. And I expect these will be fine because we've already measured this one at the other end, which is the 3.5 megahertz one, which was, I think, is on pin 6 of the CPU. That will be the other end. But the I want to see the Q one, the one that comes from the... What happens is it comes... The 14 megahertz comes from here and it gets divided down inside the ULA. Pretty sure that that side of it's okay. But there is another crystal one here, which is to do with the video generation, which is this... What is it? A 4.43 something megahertz one. We'll get into that one. I think that's X2. We'll get into that one further into the schematics. But let's just check these signals first because something ain't right. Let's try the clocks first. So Q is the clock going to the CPU. Yeah, that doesn't like me probing that one. Okay, that's a better looking signal now. Right, so I just had my probe set wrong for measuring clocks, and the actual clock signal is 9876543.2. That looks normal. Oh, it looks like it must go through a buffer or something before it gets to the clock, to the actual CPU. I've not looked at that side of it, but that looks normal to me. Now the video signals are down here on 15, 16 and 17. So we start from the other end, looking at Y, so 19, 18, pin 17. I think that looks normal to me. And then pin 16 is bouncing up and down. And this is pin 15, which is the U signal. It doesn't look as strong as the others. Something else to check is the LM1889N is getting its voltages. Okay, so on this page here, I've got the pinouts for the LM1889N and the associated circuitry for the video generation. This corner here is just a part of the ULA chip with the video output signals coming out of it. So I can trace everything around there and make sure that everything is doing what it should be doing. X2, the crystal for X2 is here. So I can check that that is doing what it should do. And honestly, looking at that crystal in there, and you see that that doesn't look right. It looks like it's possibly got damaged in some fashion. It might be that, I don't know, it could be a problem with that. It's got a blob of solder on this corner here, and it's not soldered, the package isn't soldered down like they sometimes are. Not on Spectrums, I don't think. Or maybe they are, I can't remember. No, it's not soldered down on this one. Right, I'm going to leave my stunt Spectrum to one side for a second and just have a little probe around. Well, actually, no. First of all, we need to make sure that the 12 volt supply is on the LM1889N. So I think that's pin 14. There's a 12 volts comes in here somewhere. I think it's there. Okay, yeah, the 12 volt comes in here, works its way through here. So it could be 3, 14, 15 and 16 are all connected to it. I'm not sure which one it is. It could be 3. It's 4.48. And after that, 12. 1, Yeah, it's 11.2. That's good. 14 is 3.7. 15 is, it says sound tank, 11.28. 16, 11.29. They look right, but I will check with the other spectrum. Right, so 3 was 4 point something, yeah. And then 10, 11, 12 was 11.66, is that right? 11, 13, 14, 11.6, 15, 11.6, 16, 11.6, right. So that is, there is something wrong there. They weren't all the same. They were not all the same as that. Let's make a note of what we've got going on here. So pin 3, 4.64. 10, 11, 12, 11.66. 14 is 11.68. 15, 11.68. And 16, 11.69. So they're all about the same. Okay, that gives us something to go on. So we could be looking at a bad LM1889N, or something that's feeding it is wrong. I'm just going to take the Steam card out just so that it's got the same set of parameters that I'm measuring here. That's not booting now. I think this needs a recap at the least. So pin 3, 4.7, that's similar. Pin 10, 11, 12, 11.77, and 13, 14, 11.8, 15, 11.8, 16, 11.8. No, they're all the same. Wild goose chase. I think the sensible thing to do here is to remove any other possible variables. And that is going to be the capacitors at this point. So I'm going to recap this. Yeah, quickly recap it and then come back. I think it might actually fix it. I think there's a good chance that this will fix this one. If not, well, it's not the ULA, and the memory is testing good, but we've seen weird things with memory tests in the past. The only other thing really in play is the CPU and the LM1889N and that crystal, but that seems to be generating what it's supposed to. I haven't measured it properly yet. I do need to do that, but I want to, before I do that, because there are capacitors involved in that part of the circuit, I want to actually make sure, although there aren't any electrolytics in that part of the circuit, they're all ceramics, but it could be like the quality of the voltage getting to the LM1889 is causing an issue, and that would certainly be something that the capacitors can contribute to. So, right, I will whip all these capacitors out and put some new ones in, and then I'll get back to you in a minute. I'm not going to show you this because, well, I've done it. Go and watch some of the other videos I've done it in. So I've recapped the whole thing, and there were a couple of dodgy capacitors in this area. These ones over here weren't too bad. The one at C25 actually seemed fine. I can't remember which one it was, but we've got, which one is this? This is a 1 microfarad. And this one has 46 ohms of resistance on it. I think that was the reset cap. And there's 22 microfarad here, which is 39 microfarad. And I'm not sure if I got this one out for no reason. No, that was just a normal one. That just fell off. So yeah, everything else was mostly in spec. So has that fixed it? So I think, well, I know if it has on. I've already tested this, but my thoughts going into this were kind of 50-50 that it would or it wouldn't. I've seen this kind of thing before, but look, if I turn it on now, and I did have the ROM missing earlier, so that's why it wasn't booting. I have got a normal boot and a stable display, even though it looks pretty mucky. So let's try and do something about that now. I'm going to mess with the variable resistors here. Try and get this as clean as possible. Well, that looks a bit better. There we go. Right, that should be good now. So let's try running diagnostics. Yeah, we've got a much better pitch quality. So a boring fix, I suppose, but it's useful to see that it can be, you know, you can have a problem, a computer that looks like it has a problem with ICs on board, but it isn't actually that. It's more to do with the underlying supply of the voltages. I'm assuming that's what's going on here in this case, that there was so much ripple on the voltages coming in that it was disrupting the video signal. I think this one's got a bad M1 line on the CPU as well. It should pick up that it's a 16K, that it's a 16K. Yeah, this appears to be a 16K. Oh, right, okay, so it's picked up, it's past the ROM, so that's okay. If it passes the ROM, the M1 line is probably okay. I think that's all we need to do for this one. Recapped. I don't need to do anything with the video generation circuit. I'm going to save that for another one. This one is a working one, so I'm not going to mess around with it. But yeah, even though the caps, I did check with the LCR meter, I did check that the caps in circuit, and they mostly looked okay apart from those really dodgy ones. Everything seemed to be all right. Let me grab a, yeah, this is one of the 100 microfarad caps that are down here on the 12 volt rails, and this is where I would have expected problems, and they are at 70 microfarad, which it sounds, you know, 30% out, but that's not the worst. I've seen much worse than that, and them still work. It's the other 100 microfarad one, and no, that's a 22. Really? Oh yeah. Here we go. This is the other 100, and that again 72, 1.8 ohms of resistance of ESR, but yeah, changing the cap seems to have done the trick. So I really can't do anything more to this one. It's a short and easy fix. Anyway, right, I'm going to pack this one up and label it back up, tick it off my list, send it back to Paul. Thanks for watching. I'll see you in the next one. There'll be quite a few of these that might start releasing more than one a week, because I've got a lot to get through, and they're going to be smaller, shorter videos if I can fix them quick enough. Anyway, let's see what happens in the next. Anyway, let's see what happens in the next one. Hopefully it's not the capacitors. Don't go anywhere. We're not done here. This is me from, I don't know, probably 3 weeks in the future. This machine, this ZX Spectrum, has been back to Paul. I sent it back to him, which, you know, it had been fixed, recapped, composite modded, and I noted that it had a bad membrane. He's plugged it in, and this has happened. Now, there's a couple of things going on there. One is the colour of the screen. This is a common thing that Paul sees with issue 2s. I've fixed them here, and they look fine on my bench screen, and they look fine on my capture. But once he plugs them into his test telly at his place, he gets this horrible blue, horrible effect. And what that is basically a problem with a weak ULA and in an issue 2 board. And we've had it multiple times. It's really difficult for me to diagnose, because I tune these using the oscilloscope, and they look fine on both of the screens that I'm using. But it could be that Paul sells it onto somebody and they get a terrible display. So it's something we want to fix. Now, fortunately, Happy Little Diodes Jim and Peter Mulholland off of the Happy Little Diodes Discord channel fixed this problem with issue 2 spec. Well, most of these problems, and some of them are going to be just too far gone, with the weak ULAs. They fixed it by replacing the variable resistors part of the circuit with a new board that you plumb in here. And what this does is upgrades this part of the circuit to the issue 3 circuit, which does away with these variable resistors and adds in a couple of transistors instead, and which they've done with these surface mounted ones on here. It's a really neat little solution, and I'm going to fix it to this one, but I'm not going to be able to test it right now. So what I'm going to do is do the mod. I'll test it again here, but it's going to look fine. And then I'll send it back to Paul, and then he can plug it in, and then we'll know. So hopefully this will be the solution that we're looking for. And I've got a bunch of these that my amazing sponsors PCBWay made for me. If you want more info on these boards, there will be a link in the description to Happy Little Diode's Jim's video that he did on these, plus a link to the PCBWay product page where you can order your own ones of these. You can get them fully assembled, or you can make them yourself. They're not too difficult to make, but it's probably better to get them assembled. So the first thing I want to do, when I got this back, there are other things that were going on, as I mentioned. When I got this back, I plugged it in and I switched it on using my screen here, and it had that flashing thing. So we've got the blue tint, but we've also got that flashing of the paper color. So it's going black and white, black and white. That was doing the same thing when I plugged it in here. So I thought, oh, what's going on there? I unscrewed the case and took the lid off, had a little look around. I touched the ULA. It might not have been the ULA itself, but that's the only thing I actually did. I switched it back on and it had gone. It was booting normally. Now I've left it all night. It's quite cold in here today, and I'm hoping that it will be in the same condition as it was when I switched it on yesterday, and maybe it will do the same thing. So I've got it hooked up to capture. I'm hoping I'm just going to check my capture. Yeah, I've got it hooked up to capture, and I'm plumbing in 10 volts rather than 9 volts. I'm actually going to increase that to 11 volts because I know that Paul uses original power supplies. I could reuse an original power supply, but that would take a long time to dig that out. So I'm going to change my voltage to 11 volts, which is going to be much more like the regulated power supply that he would be using. And that's ready to go. So here we go. I'm hoping it shows a fault. It does. Look at that. That's really interesting. I'm actually going to leave it running, and I'm going to pull the video lead out and plug it into my TV. And it looks fine on my TV. I mean, the picture's just still warming up, but that looks perfectly normal. This is really good. Let's go back to capture, and it looks fine on capture. What? It must be so marginal. But I haven't got that flashing thing, and you can see the diagnostics starts up perfectly normal. That's started perfectly normal this time. So it's an intermittent fault at my end, which is difficult because I can't reliably test it. But I'm fairly sure it is down to this part of the circuit not being as reliable. I could probably, and what they probably did back in the day, is replace these 2 variable resistors. And I do have replacements for them, but I think it's more to do with the ULA being faulty, not faulty, but tired, and in a combination with this not being the best. So I'm going to stick this in here by following the instructions on their GitHub, not their GitHub, PCBWay page. So this is the mod completed, not my one. This is a picture of it that I printed out from Jim's video. So I've got to fit a resistor in here. I need to find that resistor first. A couple of flying lead wires here, and I think that's a ground point there. Let's have a look. Yeah, this one's ground. That's 5 volts, and Y is the yellow one. So I need to fit that, and I'm not sure what this one does, but yeah, go and watch Jim's video. And there's a number of components I need to remove, so I'm just going to heat up my soldering iron So yeah, this mod will remove the trimmers from the Issue 2 ZX Spectrum, potentially getting more life out of ULAs that won't tune easily, but ultimately removing the need to open the case to adjust the picture, as featured on the Happy Little Diodes YouTube channel. Highly recommend Jim's channel. Absolutely brilliant. His technical knowledge is really, really good. And working with Peter, who's a genius at this sort of thing, they've come up with this very, very clever solution. So installation steps: I need to remove R38, 39, 40, 41, 56, 63, C52, C53, and VR1 and VR2, and then fit a 470 ohm resistor between right terminal of the four. Yeah, look, let's do that. Right, I've made myself a map of all of the components that I need to remove. So I'm going to get those out first, and then we'll work out the rest of it. All right, I've just noticed all of my I didn't clean up after myself the last time I fixed this. So all of my marks are still on here from recapping, but I've added some new marks here where I've got to remove the components. And obviously, like every ZX Spectrum ever, all of the component leads are folded over like this. So I'm going to have to stand them up first before I can get the desoldering station onto them. This is probably the hardest part of this. Right, that's all the legs stood up on the resistors, and the capacitors. I've still got to reflow the variable resistors as well, so I'll just quickly do that. Right, let's pop those variable resistors off first. They got nice big pads. And now I realise I've forgotten to straighten some of the leads on this side. Quickly do that. Right. Oh, that's moving nicely. Okay, so we've got variable resistor there. A little bit of flexing, and another variable resistor there. And then we've got that. That one. That leaves this, looks like a decoupling cap there. Got 3 here to come out. And a couple up here. All removed perfectly. That's really good. So now this goes in here. Ah, right. So it actually says on the mod board C52, R56, C53, R63. So C52 is that one on R56. So it's the bottom 3 of those removed components there, and the bottom 3 of these components here. So that's going to go in there. And then I've got to connect a flying lead to a couple of points up here next to this variable capacitor here, and then feed in the ground, and then do that mod over there somehow. So where's the ground? Okay, so they're using that point there for ground. There's also that one there. You can use either of those points there, or that. The end of that capacitor there is also ground. Right, and then I still need to find a 470 ohm resistor and connect up these other 2 points. Okay, so I've been scratching my head for a little while because on the Happy Little Diodes version of this, if you actually look at the layout of the board, there's two vias, one just there at the end of my tweezers. That's the 5 volt. It's got a V next to it. And the one above it is the one for the Y signal, which is supposed to be connected to pin 17 on the ULA socket. And I checked that. I just wanted to make sure that I wanted to see if there was a different a via that I could get that was maybe a bit better, but there isn't. This is the one, but it's not connected to there. And I'm thinking, why? I mean, it's right there. I must have a trace break. So I got this scrap board. I removed the socket kind of untidily. There's still a pin sticking out here. And there's no direct connection between that point there and pin 17 of this socket. There is no direct connection. What actually happens is, I mean, if I trace this out, if I buzz this out now, that's connected, but there's no trace between these 2 points. And what actually happens is this trace heads off over here to one of these resistors over here. And then it comes back through this link wire here, which is marked Y under the LM1889 end, and then back to that point over here, and then into the variable capacitors and resistors. Now, on my board, or on the faulty board, that jumper's not populated. That link is empty. So that point there over there, and whatever else it connects to, isn't connected to anything. So I just need to stick a jumper wire in there. That's all I need to do. Right, to save me a little bit of hassle, I'm going to solder that from the top side. Luis Carrera style. There we go. Now I should have a connection between pin 19 and 17 and that point there. Yes. Phew. That had me going for a little while. I was thinking, these Spectrum boards, they're not the same. They're both issue 2s, but they're not the same. Right, I still need to connect a couple of wires up. I don't think they need to be these big heavy wires. Be quiet. But I've lost my thinner gauge wire box. Can't find it anywhere. And in Jim's version, he's used big, heavy, chunky wires because it was the only wires he could find. And he used the excuse that it would give it some structural stability on that side of the board. And so I'm going to stick with that. But I'm going to do it slightly different just because I'm going to put one wire in one side and one in the other side, just to make it a bit easier to route them. And that's going to go in here, like that. Yeah, that fits into that via. Now I've got to do the same for the yellow wire. Right, see how that fits. Just remove the solder mask off the wires on the other side with a little dental tool. It's handy, that. Right, I've got both wires through. The 5 volt's not gone through brilliantly because I tinned that one, but there's enough there that I can solder it. But the Y wire has come through nicely on this side, so I can get a good connection on that. All right, that looks good there. I just need to poke this into the right holes. Like that. And then solder all the legs in place. And don't use my Nipex cutters on these pin header legs, because it will wreck them. And that's nice and solid, that's not going anywhere. I don't know if the variable capacitors still do anything, but I'd be interested to see what happens with those. There we go. Is that going to have actually done anything? And how will I know? In the words of Whitney. Okay, I've got it all connected back up. Got the ULA back in. I think everything is... Oh, I haven't got... No, I have not got the ground connection done, which needs to go to there. And I haven't got the 470 ohm resistor done. So let's not do that yet. It's all right, Lee, edit that bit out. Nobody will know. 470 ohm resistor between the pad of R41 on the right hand side and 5 volts. Use 5 volts, which is connected directly to the output of the voltage regulator, which we've hit them. They found there's a big trace there. So that is 5 volts. So that's not. That's 15 ohm. 15 ohms of resistance on. There's a trace just there at the top of that capacitor that is going through a 15 ohm resistor. So there's another one there. What's this? But that's on that side. So rather it was... There's another one there as well. I think I'm going to do that on the other side. Okay, got a 470 ohm resistor, and I've worked out that I can connect it to a point down, just down the road from there. So I'm just going to poke that all the way through there. Make it turn a corner. Yeah. Just so I don't short, this is obviously ground here, so I don't want to short out on there. I'm just going to solder that in place at one end, like that. Right, there we go. That's, I think, a bit neater on this side. And I just need to remove that from this side. And then I'm going to use this as my ground lead on this side. No, maybe I will use the same one. Yeah, I'm going to use the same one, but I'm going to put a component leg in there. Right. Yeah, stick a ground lead in there. Like that. Right. Now it's complete. Let's try that. Will it explode? Still got 11 volts going into it, but that's fine. The regulator can handle that. Here we go. 1, 2, 3, 1, 2, go. That seems to work. Let's try it with the Steam Card Pro in, so it's got some colour to... Yeah, looks good to me. I'm going to change the two capacitor transistors at TR1 and TR2 to brighten the image up so that we get the full effect. These haven't been changed, but I just want to make sure that I'm getting the best image possible. Nothing wrong with those transistors at all. But with a composite mod, the picture is a bit darker, and these BC549s will just boost it up a bit. Make sure I put them in the wrong way around. All right, that should, on my capture at least, brighten the picture up considerably. Here we go. That looks good. That looks good. It's a bit noisy, but I'm using a switching power supply, so it could be down to that. I'm just going to try it on my screen over here. Yeah, it looks really good. For a composite signal, it looks really good. I fiddled with the capacitors a little bit and slowed the dot crawl down. It seems to be a much more stable image. Now, the keyboard on this didn't work at the end of the last video. And when I tested this, I put the keyboard back in earlier and the keyboard was working. And the membrane is in a shocking condition. It needs a new membrane. It's really in poor condition. But I'm pretty sure it was actually working. Yeah. And you know what that means? That means we can play a bit of Manic Minor. What on earth has happened there? Oh, no, that's because it's 48K. It's not going to work. It doesn't work with 16K Spectrum, so I can't play again. I'm not going to play Manic Minor at you. Oh, I didn't know that my dandinator did that. Okay, so that's buttoned back up. I'll give it one final test. Now it's got all the screws in place, just to make sure that nothing is untoward. And that seems to be okay. So I'm going to package this back up in the box that Paul sent this to me with a kilo of licorice cola bottles. I'm not sending the cola bottles back. And I'm going to send it back to him and get him to plug it in. And hopefully he'll send us a little video and then we can wrap this one up. I've sent it back to Paul and he's got it back and he's plugged it in and switched it on and yeah, it's not working. It's a bit disappointing, but in this case, I believe this is down to just a ULA that's tired and refusing to output the correct colour balance levels. I don't entirely understand it, but what I'm hoping is that someone like Peter Mulholland and Jim from Happy Little Diodes will look at this and go, well, maybe it could be that, and give us a good idea of what this could be. Anyway, this one's out of my hands now. This will be, I think Paul's selling these off cheap, the rubber key Spectrums at the moment on some Facebook page somewhere. I'll try and put a link in the description for it. But anyway, this one, while it's not a win, well, it's not a win, is it? It's just one of those things. It's a machine that we couldn't bring back all the way. Well, it could be brought back. You could put a new ULA in it, but that's going to add another £25 at least to the cost of fixing it, and that's most of the value of the machine. So it's not financially viable for Paul to do that, but somebody else can buy it off of Paul for not too much money and do that themselves quite easily. It's already recapped. It's quite a nice candidate for a 16K machine. I'm disappointed. I hope you're not too disappointed, but I hope you enjoyed the video and the journey along the way. Let's fix something properly next time. All right, see you next time.